These are the three acids that I'm going to be pouring on my hand. From left to right, we have muriatic acid, sulfuric acid, and nitric acid. I chose these three acids because they're the most commonly used ones in the lab. The question that I imagine a lot of you are thinking is, why would somebody purposely pour acid onto their hand? I could in fact just be crazy and stupid, or I could have a logical reasoning. The main reason is to show the effects that these acids have when you get them on your skin, and to show that you really should not freak out. For acids like these and many other types of acids, damage to the skin requires prolonged exposure. As long as the acid is washed off in a reasonable amount of time after it gets onto your skin, there really isn't much to worry about. The second reason is a little bit more abstract, and it's to illustrate how chemicals have different reactions with different things. In general, the reaction that occurs between two chemicals is very specific to the chemicals that are involved. Just because something has a violent or scary reaction with one thing, it doesn't mean that it'll have the same reaction with everything. This point will be further elaborated on as we go through the video. Before we start, I really want to have a disclaimer and state there's a very big difference between corrosive chemicals and poisonous chemicals. The acids that I've chosen, and a lot of other acids in general, are simply corrosive and they're not poisonous. When corrosive things get onto your skin, usually if you wash them off in a reasonable amount of time, the worst thing that can happen is some red irritation or some pain. With poisonous things like, let's say, mercury salts or some other things, getting it on your skin is a much bigger deal. This is why it's extremely important to know what you're working with before you work with it, and to have the proper safety precautions in place. Knowing what you're working with and all of the associated risks and dangers is extremely important before you start any project. One other point to make is that your skin is not like your eyes. If you put acid on your skin, it can regenerate. If you get acid in your eyes, you can go blind extremely quickly. A major reason why these acids don't hurt your skin very much is due to the dead skin layer, and you do not have this on your eyes and they'll be severely damaged. So with that being said, I'm going to get started, and we'll start with muriatic acid, also known as hydrochloric acid. So here we have some 31.45% hydrochloric acid that I bought from the store. To start off, I pour a little bit into a beaker. I add another beaker and I place some aluminum foil inside, and then on top of this I pour in some of the acid. I did this for two main reasons. A, to show the violent reaction that it has with aluminum, and B, to show you that it actually is acid that I'm pouring onto my hand. One thing that didn't occur to me was that aluminum has a thick oxide layer on its surface which protects it from the acid, so it takes a little bit of time for the reaction to start. However, you can see that the moment it started bubbling, the reaction took off pretty quickly. I also purposely did this in one shot and kept my hand inside the frame the whole time, so that people wouldn't claim that I swapped out the beaker for water or something. Anyway, once everything's reacted, I figure I'm done with it and I move it to the side. I then decide that my left hand is the victim, and I start pouring the acid onto it. Before anyone comments, I am double jointed, and I'm also well aware that my hands are not exactly beautiful. I definitely do not qualify to be a hand model, and pouring acid on them really isn't going to make them any uglier. From the moment that the acid touched my skin, I started a timer, and I'm going to hold it here as long as I can until I start feeling a little bit of pain. The moment I start to feel a little bit of stinging, I will remove my hand and rinse it in some water. You can see I really felt nothing, so I started even giving my hand a little bath in the acid. After this bath though, it started stinging a little and I decided to wash it off. So in total, I had the acid on my hand for about 50 seconds. After washing it off, it wasn't red or anything at all, and I figured I'd move on to the next acid. And now for the scarier acid, which is concentrated sulfuric acid, and as a quick demonstration, I pour a little bit onto some paper towel. You can see that it pretty quickly reacts with the paper and dissolves it. I didn't hold it here for long enough, but it would only take something like 10 seconds to fully dissolve through a few layers of paper. So, with this demonstration done, I move on to pouring some of it onto my hand. Before I do this, I apologize for the poor angle and also for my sloppy pouring. I honestly have no idea why I poured it like this or why I was so sloppy, but unfortunately this is one of those things that you can only do one take of. In either case, I still poured a bunch on my hand and the effect will still be seen. I honestly thought it was going to burn pretty quickly, and this is why I put my bucket of water right next to it, but it honestly wasn't that fast. I washed my hands off immediately the moment I got a slight sensation of burning. After washing it off like you see here, scrubbing and making sure that there's no acid left over, there was absolutely no pain. So I was very surprised to see that I could hold it on my hand for something like 25.5 seconds and feel absolutely nothing. This is the aftermath after I washed my hands, and you can see the damage that the acid did. What's interesting is that these aren't burns, they're just really dry skin, like if you leave a wet band-aid on for a day. Sulfuric acid loves taking and holding onto water, so the moment it touches your skin, it immediately pulls the water out. When water and sulfuric acid mix, it's exothermic and produces heat, so this is why when sulfuric acid touches your skin, it actually feels slightly warm. This is what my hand looked like about 3 hours later after I put some moisturizer on it. You can see there's no real damage and it just looks like wrinkly, dry skin, and just to show that there's no pain at all, I hit it a few times. I also compare my left hand, which got the acid on it, to my right hand so you can see the difference. So now onto the last acid, which actually turned out to be the worst of them all, which kind of surprised me. So into a beaker, I pour in a little bit of concentrated commercial grade nitric acid. My demonstration for this one is the reaction between nitric acid and copper. Nitric acid will react quickly and very vigorously with copper. It will produce a green copper nitrate solution, and it will also produce a lot of red nitrogen dioxide gas. For this part of the demonstration, I had to wear a good respirator because nitrogen dioxide gas is actually quite toxic. My foolish mistake was pouring out the contents of the beaker and allowing the penny to continue to react while I do the demonstration. This produced a crazy amount of nitrogen dioxide gas and was really unnecessary. Anyway, I get to pouring the nitric acid onto my hand. Unlike the other runs, this was the shortest amount of time I was able to hold it on my hand. So it was less than half the duration of the sulfuric acid run, and I held it for only about 12 seconds. Also, unlike the other times, the stinging and the pain ramped up quite quickly instead of being very slow and gradual. Whereas with the nitric acid, I really felt it attacking. I think this is actually for two major reasons. The first one being the obvious, my hand was already assaulted by acid twice earlier in the day, and the second reason being that nitric acid actually reacts with your skin. It reacts with a protein in your skin called keratin, which is what gives your skin its elasticity and its strength and its ability to repel water. I think this factor and the exposure to the other acids compromised my dead skin layer and allowed the nitric acid to penetrate deeper. This is my hand, and you can see that it's a little bit red, but there's a lot of yellow. As I said before, nitric acid reacts with keratin in your skin, and when it does this, it turns it yellow. This effect, though, is mostly just superficial. I read online that when these stains were neutralized, they go from a yellow color to more of an orangey color. So I couldn't really resist testing this out, and I soaked my hand in a saturated solution of baking soda. When I took my hand out, it actually did look like some of the stains turned orange. There was still a lot of yellow, but I could definitely see a little bit of orange. This is the aftermath, and it shows what my hand looks like about a week or a week and a half later. Basically, there's no real damage to my hand, it's all just superficial, and all of the skin that the nitric acid destroyed just flakes off. My hand looked horrible and diseased from all of the skin that was flaking off, but by now everything looks perfectly fine. So you can see here a shot of what my hand looks like now, which is about a few weeks after I did this. It pretty much looks exactly the same as the hand that didn't get the acid, because by now all of the dead skin has had time to fall off. So in this video, you saw me put 3 different common acids onto my hand. I really want to illustrate the stark difference that these acids had when reacting with, let's say, the aluminum, the paper, or the copper versus my hand. These things had violent or scary reactions almost immediately, whereas with my hand, it didn't really seem like much of anything was happening. This is the nature of chemicals and chemical reactions in general, where the reaction is extremely dependent on what is actually present. Just because something violently reacts with one thing, you can't just assume it's going to violently react with everything, because as you can see here, that's clearly not the case. On the flip side though, just because something appears to not react violently with something, it doesn't mean it's going to be safe with everything. For this reason, you should always wear gloves and always take the proper safety precautions because you don't know everything. Although accidents do happen and you will probably end up with a little bit of acid on your skin, and I hope this video showed you that you really don't need to freak out and you just need to wash it off as soon as possible. I would imagine that the average response time is several seconds and not 20 or 50 like I had here. Anyway, that's it for now. I hope my point was semi-clear in this video because I know it might have been a little bit convoluted. That being said, don't extrapolate the conclusion of this video to every single acid. As a side note, in this video I only use strong acids, but a weak acid could potentially actually damage my skin more. The terms weak and strong only refer to its hydrolysis in water and not to how damaging it could be when it gets on your skin. Again, here's a list of the videos that I'm currently editing and future videos I plan to film. In the videos being edited category, you can vote for the one that you want me to publish next, and in the future video category, you can vote for the one that you want me to film next. Also, if you're feeling generous, please donate to my Patreon account because with a bigger budget per video, I can do more things. Also, instead of stockpiling videos, I've decided I'm going to publish them as soon as I edit them, so in the next month or so, there's going to be a lot of videos coming out. On my Patreon, I also added a milestone, and if we get to $250 per video, I'll commit to doing videos for at least 6 months.